This is the third of 3 lessons on grid navigation. We will start by reminding ourselves about grid convergence and then go on to the solution of grid problems. A gridded chart is invariably used in polar regions. In both the North and South polar areas, the common plotting charts are polar stereographics or transverse or oblique Mercator's. On all of these charts, the 360 degrees of longitude on Earth are represented by 360 degrees on the chart. This property makes these charts ideally suited for the use of a standard polar grid, which can be printed on the charts for all users. The Greenwich meridian is usually used as the datum meridian. This is a polar stereographic chart, and the grid track from A to B is 090 degrees. We're going to work out the relationship between true and grid track at various points. In order to do that, we'll need to use the east, west, west, east rule. Position A is at 70 west. As the datum is Greenwich, this is west of the datum, in the northern hemisphere. This is easterly convergence. Convergence east, true least. The true track will be smaller than grid by 70 degrees. 090 grid minus 70 degrees gives us a true track of 020. We now continue a long track until we reach longitude 45 west. Again, we are west of the datum. Convergence east, true least. The true track will be 45 degrees less than the grid. 090 grid minus 45 degrees gives us a true track of 045. As we pass the datum meridian, the true and grid tracks are the same. As we get to 45 east, we are now east of the datum in the northern hemisphere. Therefore, convergence is west. Convergence west, true best. The true track will be 45 degrees more than the grid. 090 grid plus 45 degrees gives us a true track of 135. And finally, we'll arrive at B, which is longitude 70 east. Again, we are at east of the datum in the northern hemisphere, so convergence is west. Convergence west, true best. The true track will be 70 degrees more than the grid. 090 grid plus 70 degrees gives us a true track of 160. This all ties in with what you learnt about polar stereographic charts. The longitude has changed from 70 west to 70 east, which is a difference of 140 degrees. Therefore, the true track of any straight line must also change by 140 degrees. In this example, we have gone from 020 degrees true to 160 degrees true. The grid track, however, does not change. Here we have a north polar stereographic projection. Therefore, the n factor is 1, and the chart convergence between any two meridians is simply equivalent to the change of longitude. We are going to work out the relationship between grid and true for each aircraft. Firstly, by inspection of the diagram and common sense, and then secondly, by use of the rules on convergence. Let's first make a point which will help you when you come to draw your own diagrams. It usually helps your thoughts to have grid north at the top of the page. In the northern hemisphere, this means having the datum meridian at the 6 o'clock position, because north is the direction that runs into the North Pole. Let's start by looking at aircraft number 1. Just by inspection of the diagram, you can see its grid heading is 360 grid, whilst the true heading is 270 true. Therefore, the true heading is 90 degrees less than the grid by simple visual inspection. Now work it out using convergence. If grid north is at the 12 o'clock position, then the datum meridian must be the Greenwich meridian. In other words, this is a standard grid. Aircraft 1 is at longitude 090 west, which means that the aircraft is west of the datum. If we're west of the datum in the northern hemisphere, convergence is east. Convergence east, true least. Therefore, true heading should be 90 degrees less than the grid, which it is. Both the convergence formula and the diagram give the same answer. Now try the same exercise for aircraft numbers 2 to 5. Do it both ways, firstly by visual inspection and then secondly by using the rules. Get a piece of paper and work out what goes in each of the blanks. When you're finished, click to continue to check your answers. Here are the answers. Now let's do it for the southern hemisphere. This is slightly more of a brain stretcher. To get grid north at the top of the page in the southern hemisphere, we need the datum meridian at the 12 o'clock position. In the southern hemisphere, north is the direction that runs out of the South Pole. You know what to do now. Just remember that convergence east and west are the other way round in the southern hemisphere. It's actually easier because you don't change the sign. Now try the same exercise in the southern hemisphere. Again, do it both ways, firstly by visual inspection and then secondly by using the rules. Get a piece of paper and work out what goes in each of the blanks. When you're finished, click to continue to check your answers. Here are the answers. Now we'll try some problems of the sort that you might meet in an exam. In these kinds of problem, there are 4 factors. These are the datum longitude, the aircraft longitude, grid track, true track. The question will normally give you 3 of them and you have to find the 4th. This one is for a polar stereographic chart. The aircraft position is 45 north, 110 west. The grid track is 132. The datum is at 60 west. What is the true track? We'll start by working it out using the rules. Is the aircraft east or west of the datum meridian? The aircraft is at 110 west. The datum is 60 west. The aircraft is therefore 50 degrees west of the datum. Is that east or west convergence? We're in the northern hemisphere. It must be easterly convergence. With a polar stereographic chart, little n is 1. 50 degrees of change of longitude is 50 degrees of convergence. So, the convergence is 50 east. Convergence east, true least. So what is the true track? A grid track of 132 minus 50 gives a true track of 082. We recommend that you simply apply the rules as we have just shown. However, we will give you the diagram solution as well, so you can envisage the situation. Firstly, plot the aircraft position of 45 north, 110 west. We are looking down on the Earth from above the North Pole. This is 110 west. Try to estimate the longitude reasonably accurately. The latitude doesn't matter on these diagrams. There is no latitude scale anyway. Draw in the datum meridian. This gives you the direction of grid north. Parallel grid north so that it passes through the aircraft position. Draw in a track of 132 grid. Now compare your grid track with your true north direction. You can see that it is about 082. With a diagram like this, you would be able to work out the correct solution from the given multiple choice answers.